Hello, puppet. How's my lab partner? Grab this. Lab today, hydrolysis. Water reactions with salts. Now, you're not going to be able to be very good at doing this lab if you haven't watched the videos on hydrolysis and reactions of salts. For what if we had met today, it would have been, I believe, the third video in, or problem 3. It's about salts and why salt can change the pH of your solution. So if you have just neutral, high quality made in America neutral water, you add a salt to it, there's a good chance that the pH of that salt will change. Become an acid, become a base. Sometimes it'll say neutral, but that's what you need to find out, how to figure that stuff out. Because if you don't do that, you're not going to be able to do any of these. And this is the data table, which is on page 2 that so page 2 data table. You got to fill this all in. All right, so you need to look at that video. Okay, so I will go through, if you and I were partnerizing, how to fill in the data table with the first salt, lead nitrate, the one right up here at the top. I will go through and I will give you the solutions to that very first one, so you can use that as a guide. All right, you have to fill in the rest of this. So, but again, you're not going to be able to do that unless you look at how to hydrolysis of salt. That video. All right, so what do you got to do? You have to fill in this data table, but you also have to do calculations. Now, we're not meeting, and this is going to be a dry lab for us. In fact, what I mean by that is no equipment. There's no equipment. You know, all the other videos, there's equipment, and I'm showing you how to do something, or I'm doing something for you. No equipment here. So what you would do is, if we were together, is you would make a solution. The whole group, the whole class would act as one lab group for this lab. So each group, I would usually break you up into groups of 2, would make one of these salts. Where are they? One of these salts. Okay. Otherwise, if you make all 7, it takes a long time to do that. So that would take a long time, and everybody's doing the same thing repeatedly. So we work as a group, and so, for example, you and I, lab partner, might have the lead nitrate solution to make, and we'd go ahead and we'd do that. All right, and I'll show you how to do that. So what I do want you to do, however, is I want you to do the calculations, even though we're not actually making up these salts. I want you to show me that you can do the calculations anyway. It's good practice. You have to know how to figure out moles and moles to grams. It's chemistry 1 sub. Now, so the first thing you might want to do, so if we were together and the whole group are together, I would assign the class a 2 molar, so here you go ahead and write that in, 2 molar, 2M, solution. So everybody would be making a 2 molar solution. Group 1 would make the lead nitrate. This group over here, they would make the sodium chloride, 2 molar solution of that. And so on and so forth. The sodium phosphate, another group would make a 2 molar solution of that. Then each group would test their results and share them with the class. So you and I, lab partner, were assigned to do this lead nitrate, and I'll go through that with you, and then we'd share that with the class. All right, so that's how we would do it. It would save a lot of time. Otherwise, this is a really long lab. We had a lot of lecture, a lot of theory with today, so it would make a really long day if we had to do them all ourselves. But you are going to have to calculate them all. Yes, you are. You're still going to have to do the calculations. I know. I ask a lot of you. All right, so if you look at calculation 1, says for each of the 7 salts, okay, calculate the amount of salt needed to make the correct concentration. The concentration is 2 molar. So you are going to have to, for all 7 salts, calculate how to make a 2 molar solution of that salt. And I will drag you through the first one to demonstrate for you. So here we go. So 2 molar. Now we all remember that molarity is equal to moles per liter. Right, okay. So you want to make a 2 molar solution. Now, if we did read, I know you haven't, probably, or maybe you have, maybe I should make that assumption, maybe you have, maybe you looked up top, procedure 5, add 5 milliliters of distilled water. So you're supposed to make a very small amount of this solution. We don't need a lot, we would dip some paper in it and test the pH, see what color it is with the indicator, and that was it. So you don't need a lot. So 5 milliliters, not very much water. You know, so there's a little bit in the bottom of a small test tube. So 5 milliliters goes here, but not milliliters, liters, right? So 5 milliliters, whoop, 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 3 places to the left, is going to be 0.005 liters. And so for each one of the 7 trials, and each one of these 7 mole calculations, you are going to use this setup, because each one is 2 molar solution, and each one is in 5 milliliters of water. Okay? Now, what's going to differ is how much of it you'd have to go back and scoop out onto a balance and mass that out. That's going to be different for every chemical. Let me show you the first one. So for every chemical, though, every one of the salts, all 7 trials, you're going to multiply these 2 to get moles. You can do that. You can do that. 2 times 0.005 is 0.01. So for every single trial, you need 0.01 moles of the salt. Okay, now, how many grams is that? Because you can't go ahead and mass out moles on a balance. It doesn't know anything about moles. It knows about grams. It knows about mass. It doesn't know about moles. You're supposed to know about moles and converting it to grams. You got to convert that to grams for every salt. All right? Let's do this one. You and I, lab partner, we're going to do this. Okay. So for every salt, 0.01 moles. 0.01 moles. And for the first salt in the line is lead nitrate. Okay, PbNO3. Lab partner, I'm doing the most difficult one for you, probably. It's the one with the most stuff you got to add up, so I'm here for you. Okay, so now moles of lead nitrate, we want to convert that to grams because balances do not know how to get moles of something. You can get grams. So we always put a 1 next to the mole, 1 mole of the lead nitrate when we're converting to grams. You remember how to do this, right, lab partner? It equals how many grams of lead nitrate. So what you have to do is you got to add all that stuff up. Ew. All right, set it all up. Lead, there's 1 of them, so I'll do this out. So I'll be organized here. There's lead, there's nitrogen, there's oxygen. I have 1 lead. I have 2 nitrogen. I have 6 oxygens. Lead is 203. So that's 203. And nitrogen is 14. So that's 28. And oxygen is 16. So that's 96. That's 14, 15, 16, 17, 9, 10, 11, 12, and 1 is 3, so it should be 327 grams if we add all those things up in the chemical. So let's go look at that one more time. 96, 106, 116, 124, 27, yeah, 327. So 327 grams per mole of the lead nitrate. So I'll get rid of this. Now that was the hardest one to add up. The rest of these are not so bad. I mean, you do have to do some looking up some stuff if you don't know all your masses. That's okay. Look them all up and add them all up to get the total mass. So let's do a mole calculation or a gram calculation. We have this many moles is what we need for every salt. And we divide by 1, doesn't change anything, and we multiply by the mass of that compound. So you always take the mass of the compound and multiply it by 0.01. Oh, we don't need a calculator for that. We're multiplying it by 0.01. So we're going to move it over 2 places. So this is 3.27 grams. So for the first salt, the lead nitrate, I would go back to the balance. It would be located in different balances. We'd have 1 for lead nitrate. We can go ahead and we take some paper, put it on there, 3.27, got it, and we carefully put it into, now with our hands, I've got paper in my hand, okay, paper man, and we put it into the test tube with the 5 milliliters of water, and we shake it around a little bit, get it to dissolve, and we're ready to go. We'd be testing it. Okay, so first thing you've got to do is calculate how many grams of each one of these 7 salts you'd have to add by adding up the masses and multiplying by 0.01. Okay, that's step 1. Calculations. Now, there is an equation for calculations. I'll go through that shortly. Let's go into how we would fill this table in. Okay, lab partner, you and I have lead nitrate. That's our salt. We've made it. We've added our 3.27 grams to our 5 milliliters of water, and it's all dissolved, and we're ready to test it. So we have to fill in this information. Now I shorten these up. These are the things at the top here, effect on the indicator. Shorten these up. pH, parent acid, strength of the base, parent base, and strength of the base. So those are all across the top there. Let's fill this chart in from the top row. Effect on the indicator. The indicator is phenolphthalein. Okay, you remember from the last lab that when you put it into a base, it turns pink, purple. Okay, whichever one. Billy said pink and Jeannie said purple. Whatever works for you. So I go with purple, but hey, you know, I'm a purple guy. So in the presence of a base, if it's in an acid, it's clear. If it's in an acid, it's clear. So what color would it be if we take a drop of it and add it to our nicely fresh solution that we made? What would it be? You can't know the answer to that, again, until you watch that video on salts and hydrolysis. But I'll do a quick recap for you. If you take this and dissolve it into water, it's going to break down into lead. So here's my water, and nitrate. It'll dissolve into 2 nitrates. Not that that matters, but it'll dissolve into 2 nitrates. So you got lead in your nitrate. So what happens is, in water, we know that water self-ionizes, undergoes auto-ionization, which means there's a little bit of hydrogen floating around and a little bit of hydroxide. Boop, 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 boop. A little bit they're floating around, right? Kind of just hanging out there. So if I am a hydroxide, I'm going to want to hook up with the lead. I want to hook up with the lead. You get Pb and make PbOH2. If I am a hydrogen, I want to hook up with the nitrate and make HNO3. And make 2 of them. That's what will happen. This dissolves in water, so it splits apart. You get lead and you get nitrate. All right, the lead wants to connect with the OH, make lead hydroxide. The nitrate wants to hook up with the hydrogen and make hydrogen nitrate, which we also know as nitric acid. This is nitric acid. This is lead hydroxide. So the hydrolysis of salts video is really important because it talks about looking at the 2 potential things that are created in the water when you add the salt. We have 2 things here potentially made. You've got an acid and a base. Is that a strong acid? I hope you say yes at this point. Yes, it is. It's a strong acid. That's a strong acid. This lead hydroxide is a weak base. I hope you know why. Okay, lab partner, I hope you know why that's a weak base. Okay, but it is a weak base. That metal, lead, is way over to the right of the periodic table. It's not a group 1 or group 2, so this is weak. Weak. So what do we have? We have a weak base and a strong acid. Who wins? Strong versus weak. Strong acid wins. The strong acid dominates the weak base. What would the effect on the indicator be? This would be an acidic solution. Because strong beats weak, it would be acidic. If it's an acidic solution, what would the effect on the phenolphthalein be? Take a drop of phenolphthalein, drop it into an acid solution, and you get nothing. Be clear. So we would write clear here. If it does turn, because if it's basic, if it's alkaline, and it does turn purple or pink, you're going to write that in, purple or pink, if that's what happens. If you have a neutral solution, and that can happen, and I'll give you a hint, one of these should make a neutral solution. Should be a clear effect on the indicator, because it's not basic yet, it's still 7. Okay, so it has to be basic to be pink or purple. Okay, what about the pH? Well, unless you actually had pH paper, which you would have had, to dip it in and check it, you don't know. But here's what you do know. It's acidic. So put pH acid, because you know it's acidic. Or you could put pH lower than 7. You could do that too. So you put acid, or you could put the pH is lower than 7. All right, with me? All right, what about the parent acid? Oh, wait, that's pH greater than 7. pH lower than 7. pH lower than 7. Okay. Go back to 4th grade. The parent acid is the acid that is potentially created, that the water would and the salt ion would try to create. What would it be? It's right there. That's the acid. That's the parent acid, the HNO3. HNO3. The strength of that acid? You better say strong. Okay, that's strong. The parent base, the base that's going to be potentially created here would be lead hydroxide. So I write that in. Lead hydroxide. Strength of lead hydroxide? Weak. Weak. So these should make sense. If you have a pH that should be less than 7 because it's acidic, it's going to be clear. That's because the acid is strong and the base is weak. The base is weak. So we filled in the top line. Now what I want you to do, and you have to know your hydrolysis and how this works. I will say it one more time. If you haven't gone and watched that video on hydrolysis and salts and how they affect pH, you gotta go watch it. All right, so your job then is to go ahead and figure out what each of those salts you put in water would make. Okay, what would the potential acid be? What would the potential base be? Strong versus weak. It's possible they have two strongs. I already gave you that hint. There will be two. There will be one of those that'll make two strong acids, or a strong acid and a strong base, two strongs, and that would be a neutral solution. Otherwise, though, somebody is going to be stronger than somebody else. So somebody will be stronger than somebody else. Okay? So there will be an effect on the indicator, and you'll have a strong versus weak. All right. So you go ahead and figure out the hydrolysis of each of those salts, predict what kind of acid, what kind of base would be made. Knowing strong and weak acids and bases, you can write in the parent acid, parent base, if it's strong or weak or not, and then predict the pH. Okay, you can do that without having seen the actual results. All right, is that it? Is that all we're doing for the lab? Fill that in and do the calculations for the molarities? No, not yet. No. Okay, you're going to love this one because it has to do with net ionic equations, and I know how much we love net ionic equations from Chemistry 1. So look at calculation 2. Calculation 2 says, write the net ionic equations for the dissociation of each salt. Okay, what does that mean? I forget what net ionic equations are. All right, let me simplify it. Okay, we'll boil it down for you. What you do for part 2, or the second calculation, is for each these going across, each salt going across, find the weak. Find the weak. Weak. Who? You are weak in this first reaction. Okay, you find the weak. Then what you do is you write an equation for it. An ionic equation, which means the ions, which isn't that hard. So here's I'll show you. I'll do the first one. So for calculation, I did calculation 1 for you. We did that out. We got 3.27. Calculation 2, I'll do this one out for you. What you do is you take your salt and you make an equation, an ionic equation that makes that weak thing, in this case the salt. So it's an ionic equation. That means ions, charges. So lead plus hydroxide would make my lead hydroxide. Now the hydroxide has a -1 charge, hence the ionic equation. Lead has a +2 charge, but you do have to have 2 of those because of the -1 in order to make your lead hydroxide. That is how you do a net ionic equation. A net ionic equation doesn't include the spectator ions. I don't know if you remember that at all, but spectator ions are the ones that just kind of hang out and don't do anything. So that would be, in this case, would be the hydrogen and the nitrogen, or the nitrate. They would be hanging out, not doing anything, because they can't stay together. As a matter of fact, this acid here couldn't stay together in the water. It would just be HNO3 floating around. It tries to get together, but it can't, because it's strong, and it stays separated. I know it sounds right opposite. It's strong, and it stays separated. But that's how it works. All right, the weak sticks together. And the weak is this. So what you do is write the net ionic equation. That just simply means the equation that shows the formation of the thing in that salt which is weak. That's weak. Write its formation equation using the ions. That's what I do. Every one of these, except for one, there's one of these that you have two strongs. Strong and strong can't stick together. Everything stays separated. So what happens with strong and strong? Strong acid, strong base. That should be a neutral solution. You will not have a net ionic equation for that reaction. So out of these 7 salts, one of them you will not do one of these, the net ionic equation. But the other 6 have something in it that's weak. And if something in there that's weak, you're going to write a combination of the 2 ions that form that thing that is weak. All right? Okay. All right. So there might be some questions on this. So maybe you have to join a Zoom session for the first time. It's like nobody shows up. But no, that's okay. That's all right. If you get it, that's fine. Like, it's great. If you don't get it, Zoomify. All right, on Wednesday evenings at 5:30 or Monday morning, bright and squirrely at 8 o'clock. All right, is that it? Are we finally done? Can we finally shut this video off? Oh my God. No. You have 3 discussion questions to do, so make sure you answer those 3 discussion questions. All right? All right, so here's what you got. You're going to give me this chart completely filled out. Nice and filled out. You're going to write 7 equations that show how to calculate a 2 molar solution for each one of the salts. You're going to write 6 net ionic equations because one of them that's strong and strong will not have one. And then we'll answer the 3 questions. Okay? All right. I know, I'm so demanding. It's terrible. Okay. All right, lab partner. I hope you can pull that off. If you have any questions, show up at a Zoom session. It's always easier than email. You can email me, but sometimes that's a little hard. So, okay, that's all. That's it. Good luck. The next time that we meet as a lab partner, you would have taken your 2nd exam already. How awesome is that? Time flies when you're having a blast.